Okay, it's Ted at FireBoard. We are back here at our surface mount assembly line, and what we've been doing is starting really from the front of the line and walking through to show everybody really what a surface mount assembly line looks like, what these machines do, and kind of like dissecting episode by episode into each of these machines. So it's almost like a little mini manufacturing, I guess, mini series. So today we're going to be digging into the pick and place machine, and this machine, the brand is called JUKI. So it's a Japanese company. JUKI actually, I think they started with sewing machines. So actually my buddy that has a t-shirt screen print shop, they actually have JUKI sewing machines, which is kind of cool. Anyway, so this is called a JUKI RS1. And the RS1 came out in around 2019, and it's a relatively new machine. Electronic feeders, so I can get into a little bit of what that means in just a second. But basically, this is the heart of a pick and place assembly line. This is where the board comes in, and the board passes through these conveyors. They call it a gantry, but this head can move around left to right, back to forth very, very fast. In fact, you have to have this door closed in order for it to go full speed, just for safety. And so that head actually has, I think there's 8 different nozzles, so it can simultaneously come down and pick. And by pick, so again, what I mentioned is a pick and place machine. That means there's 2 operations. The first operation is pick. And so literally it would be like, if I want to pick up a single part and put it onto a board, I have to pick up that part first, right? So essentially it comes down with a nozzle and uses vacuum, negative pressure to suck up that part and essentially hold that part. So it's picking it, so you have to program the machine, where to get the part from. Of course, the parts all come in these feeders and they come in these reels from our distributors. You know, that you buy resistors or capacitors, they all come on these huge reels, and you know, it's maybe hard to see, but these things are itty bitty. I mean, these are almost just like, I would say it's a medium, size flake of, like pepper. So it's almost like just bits of pepper that you would sprinkle out, and that's the size of these components. So it's just crazy. These are size 0402, and the size actually gets smaller. They go down to 0201. It's kind of a weird numbering scheme. I think it's kind of a metric way of measuring these component parts. But each of these reels gets loaded onto these feeders. So each one of these, and these can pull out of the machine, but this is called a feeder. And as the name implies, I mean, it's feeding the parts into the machine, right? And so the machine is able to pick from this feeder, and the feeder advances. So once you pick a part, then it basically advances to the next one, so it can pick more. So it essentially just rolls through the whole tape. And these are electronic feeders, as I mentioned. So you can actually program these. If we wanted to, we could actually say, hey, look, we have a certain component, whether it's a resistor, capacitor, transistor, whatever we have to be, we can actually tell the feeder what it is, and then the machine will track. So let's say that it misses a part, or let's say that for some reason we stop the program and it drops the part. So actually we'll keep track of how many parts we've used, and so that would essentially update our inventory system. So even if we built 1,000 boards, but let's say it dropped 20 pieces, so then our inventory system would be updated to reflect we had 1,020. So anyway, it's a smart system. It's pretty cool how it works. I won't dig in through all those details, but one thing to show you in terms of just how this works, again, the pick, and then it has a place. So the place, if you imagine there's a board, here's a board. This guy could essentially be in here like this, and it would be placing components onto this board. And you can see there's actually on the surface of this board, this is a black one, so it's maybe a little hard to see, but there's little components placed on the surface. That's why we call this whole process surface mount technology, SMT. So for those of you out there that have heard about this operation, those of you who are interested in electronics manufacturing, that's kind of why we're doing this series. We thought it'd be fun just to kind of walk you through a little bit more of a deeper dive as to how this process works, how these machines work. This is kind of like the front end interface, right? This is their user interface that they've designed. One thing that we do when we start, we basically go to warm up. And so I can say, hey, let's run warm up for 5 minutes. And I hit this green button. And so what happens is, yeah, there's some noise. It's running the vacuum. It's also running the positive air pressure. And then it's running the X and Y. And the Z, it basically You can see that dropping down. That's where it drops down to pick up those parts and to place those parts. So it's just doing a warm up. The whole idea is that these motors take a few minutes to kind of get up to speed. And therefore, when it's basically doing its self-calibration and these boards come in and it's checking the alignment and measurements, that things aren't changing as it's getting up to temperature. So we get it up to temperature first, and that way things are as precise as they possibly can be. So we run through the warm-up, and then essentially the machine is ready to go. We'll call up the program, and I think that might be just super quick. I'll show you guys how that looks. And again, this is provided by JUKI. Their machine, or I guess their language, I guess, to running the machine is called JNets, and you can go into what's called the program editor. And so it's whatever program we have loaded, and we have lots of programs. Yeah, most of these programs are actually front and back. So we'll actually run a PCB through. So again, the PCB printed circuit board, we'll run that bare board, we'll put the components on the first side, and then we'll flip it over and then put the components on the other side. So essentially most of our boards are double-sided. So it takes 2 times through the surface mount line to get everything done. So just, you know, this may be hard to see, but I think it's just kind of interesting. What you have is you have every single component and placement on our program. You have the XY coordinates, you have the angle, the rotation. And so we basically take the data from our CAD software. We design the board, and that happens basically right over here. So we design the board, and that's just a computer 2-dimensional file, basically. And so you have XY coordinates. Each one of those components has a place. And so that gets translated into this machine program. And then we can tell it which type of head to use, how big it is, all that stuff, right? Which feeder we're using, of course, as I mentioned. So each feeder has to be aware, or at least the program has to be aware of what component is loaded in what location. And then once the program all is checked out, we start to run it. We do a trial run. You know, there's a little close up here of this guy, which is kind of cool to see. We do a trial run. Once everything checks out with the trial run, we test the board, and we will actually test an entire board. We'll build the entire board, a single board, and actually do a whole functional test to make sure it works before we run our entire 1,000 boards or whatever the build is. And we usually do a build of 1,000 boards. It's kind of a nice even round number, kind of easy to do. And then one thing to maybe note with the way we do things here, there's 2 trolleys. So what I've done here is I've lowered the trolley, which lets us pull this whole trolley out. And for one thing, you can kind of see a little bit closer in terms of what is inside of this machine. This lets us start to load these components. So if we wanted to reprogram, or I guess retool the machine, we'd pull this trolley out and we could start pulling off these feeders, changing everything over, grabbing new components and what have you. And we can also go back, stand inside of the machine almost, and you can start to get a sense of, hey, if I need to clean one of these nozzles, if I need to check for grease, you know, there's these ball screws here. So there's an X-axis ball screw that has to have grease. There's also a Y-dimension ball screw that has to have grease. So it just kind of lets you get inside the machine a little bit more for some maintenance. And you have nozzles back here. And then on the back side, you have the entire, almost a mirror image, another bank of feeders on the back side of the machine. So this lets us load up. Some feeders are wider than others, but theoretically, if you have these really thin ones, you can load this all the way up to 56 feeders. And so then you've got 56 on the other side. That lets us actually load top and bottom side of the board all at once. So we don't have to retool the machine when we flip from top to bottom. So that's kind of cool. We can actually very rapidly test the board and then proceed right into production. So anyway, I hope this was interesting. We're just trying to do a little bit of a deep dive. We don't want to get too much into the weeds, but it's kind of fun. You know, we like manufacturing. This is out of our Kansas City headquarters. And, you know, it's kind of neat to be able to show you guys through. It's not every day that you're able to actually kind of come in live and take a look at some of these machines. So it's kind of fun to do a little bit of under the hood, if you will, look at this. So we're going to continue. So, you know, let us know if you like these videos, if you want to see more. It's kind of fun to do. We'll keep walking our way down the line as we go. So stay tuned. Thanks.